All right, in this problem we're mixing three solutions: silver nitrate, sodium bromide, sodium cyanide. We're wanting to know if there's a precipitation that occurs that would be indicated by a cloudiness. So what we first want to do is calculate the concentrations of the silver ion, which is going to possibly precipitate with bromide or cyanide, okay? So to calculate the concentration of silver ion, we need to use the dilution formula. And we want to know what the final molarity is when all of these things are mixed and diluted with water. So the initial molarity is 0.01 molar silver ion, and we're adding 1 milliliter of that to a flask that's being diluted with 250 milliliters, okay, total volume water. So on our calculator, let's get that value there. I get 4.0 times 10 to the minus 5th molar silver ion. Okay, let's do the same thing for bromide. We're starting out with 0.1 molar, 1 milliliter, diluting to 250 milliliters. That's going to be equal to now for cyanide, the concentration and the volume are exactly the same as sodium bromide. Okay. Now, we possibly could form silver bromide, and that has a KSP value of 5.4 times 10 to the minus 13 in the table I'm using. Silver cyanide has a KSP value of, it's not here, let me Google that really quickly. So I just type KSP and then AGCN. And one of these websites I found says that it's 1.6 times 10 to the minus 14. Okay. So let's write out each one of these in sequence. Silver bromide is in equilibrium with ions. And we want to calculate the K, or the Q here. So the Q is the concentration of silver, which we calculated was 4 times 10 to the minus 5. Bromide has a value of 4 times 10 to the minus 4. Okay, and we want to punch that in our calculator. And I get a value of 1.6 times 10 to the negative 8. Okay, and at this point we want to compare that to the KSP. Q, right, which is 10 to the minus 8, is greater than KSP, which is 10 to the minus 13. So a precipitation occurs. PPT means precipitation, or precipitate. Let's see if silver cyanide, we've answered the question, but let's see if silver cyanide precipitates. So that equation looks like this. Notice that in these balanced chemical equations, there's just one of everything. The coefficients are 1, so it's a little bit simpler to do this type of problem here. Q is a silver ion, which is 4 times 10 to the minus 5. Cyanide is Cn minus. That is 4 times 10 to the minus 4 molar. Okay. And that gives us a value of 1.6 times 10 to the 10 to the minus 8. Okay. And so here again, Q is larger than KSP, so precipitation occurs. Okay. Which one of these would precipitate out first? I would suspect that the one with the lower KSP would precipitate first, so that would be silver cyanide. When silver cyanide precipitates, the silver ion decreases in concentration, and one has to wonder if there's enough still for the other one to precipitate. But this problem doesn't ask too much about that. It just says, will cloudiness be present or not? And the answer is yes. Okay. All right, thanks for watching.